again, we've done left sums and right sums and midpoint sums and trapezoidal sums, right?
Right.
What's left?
Okay. The question is, can we determine if they are over or under estimates?
Yes.
Okay. Mostly. Okay. We can approximate. Okay, let's say calculate left Riemann sum with two subintervals. Okay. There's a basic question we can answer right now, right?
Yes.
Right. So just give us a visual. It's a left sum. So we are going to have one rectangle actually, right?
How do you read that integral thing? The weird F
Integral from 0 to 2.
So the bottom one is your start point?
That's your start and your end. These are called integrand limits. Okay, so you'll hear that from me probably. Or limits of integration. It's just the start and the end points. Okay, so that approximately, if we're using L2, how high is that?
0.
0 times 1 plus,
1 times 2. Or 1 times 1.
and how tall is the function of the x value of 1? 1, right? So 1 times 1. So we have an approximate area of 1 unit squared, right? All that we've done. Okay, the question that you will probably see is L2 and under or overestimate for this integral. Justify your answer. You can look at the graph and see the answer, right? It's an underestimate. Okay, it. L2 is an underestimate.
For the integral of 0 to x squared dx.
Underestimate, estimate. There's the trick.
L2 falls under.
Okay. Most people at this point will say the rectangles are underneath the curve. That is not.
Because the left corner of the rectangle.
Yeah, we're logically describing this in our brains right now.
Oh, because the left Riemann sum is less than.
In calculus terms,
Yeah,
we have to use calculus to justify this.
yeah.
Can you say this left Riemann sum falls under the curve?
You could say that,
Would that be
but
valid?
you could say that, but you have to still justify it.
Well, then you just do the right Riemann sum.
Because the graph of x squared is increasing on 0, 2.
Isn't it the same thing as saying it's falling?
So you have to justify left and right Riemann sums over and under estimates with increasing or decreasing. How do I show that function is increasing?
Just by the derivative.
Yep. So you actually have to justify the answer by calculating the derivative and showing the derivative is positive. Okay. So that's justifying your answer. This is explaining an answer, right? But you have to justify it with calculus, right? So we are going to justify this by calculating the derivative.
Well, can you just say underestimate and then do the math? You don't have to do all that wording stuff because it's the same.
Yeah, you can eliminate all of this. You don't need this. You have to state increasing.
You do have to say
But,
increasing, but you
okay.
just have to.
So there's your critical value, right? 0. And we do our sign analysis on the interval, 0 to 2. If there are any critical points in here, we have to manage those. So f prime at 1 is what?
2.
Yeah, positive, correct?
Alright.
Okay, so this is just shown what we said. We are now justified.
Oh, that's it?
Yeah.
Okay, cool. That was nice.
So you have to remember, left Riemann sum increasing function is an underestimate.
So for the
It's a left Riemann sum with decreasing, what is it?
Overestimate.
It's an overestimate.
So why?
Then you have right Riemann sum,
which is always an overestimate.
it's its opposite, okay? So
Question.
over and underestimates with left and right.
At the top, there was a random squiggle and an arrow that said integral. What was that squiggle?
This is an arrow,
Two.
says start,
Okay.
random squiggles.
Wait, what does it say, like?
Start and end, that's the start and end point of your integral. Those are integrand limits, that's what they're called.
Okay.
Or limits of, you can call them integrand, because this is an integrand. Integrand limits, you can call them limits of integration.
Okay.
Will you
Okay.
go back down?
All right, so this is an underestimate. L2 is an underestimate because x squared is increasing on the interval. And we've shown that with the derivative. Okay? All right, what if I put R2 up here, draw it in. R2 is an
Overestimate.
overestimate, right? Because
It's over the curve.
x squared is increasing.
Well, how'd you get two ends?
I don't know.
I actually watched you draw an
I know.
eye.
Trust me, I know. It threw me off. X squared is increasing.
That just blew my mind.
I would guess, because I take this pen off the board about as little as I can. Just a habit of a guitar player, you pick your finger up as little as possible, and it probably sensed that it was there and wrote it. So notice the opposite here. L2 is an underestimate if we have an increasing function. R2 is an overestimate if we have an increasing function. They're opposites, right?
Do
Does
you
that make
say
sense?
x squared is increasing, or do you have to say?
Or f is increasing if it's f of x equals x
So
squared.
you're referring to the position right now?
You're referring to the function that we're working with. You can't say it. If you said it here,
No, I was saying like.
there's a lot of different its in this problem. You got x squared, and you've got R2, and you've got an integral, and you've got a whole bunch of stuff hanging out. So we need to be specific. Technical writing is very specific. So be specific.
Well, I was asking like you have to be more specific, like make sure that you're saying it's the position, not the derivative.
That context is with motion problems. We're not an emotion problem. Justin Smith.
And I got
$7.
Nick Wells in there too.
And Nick Pittbauer.
Is that it?
Yep. Okay. Are you okay with that?
Yes.
That's an increasing function. The function is increasing. The difference is R2 is an overestimate, L2 is an underestimate. Okay? All right, so so what about a decreasing function?
L2 is above the curve.
This thing's going nuts. Oh my goodness, what did I just do?
Did you break your,
You moved the bar
you
to
need
the
to
other side.
recalibrate it?
Oh, what the?
Do you need to recalibrate?
I don't. These don't need calibrated.
Because it's on the projector.
Okay, we're good. Dodged a bullet there.
That'd been really weird to get used to if it was stuck on the other side.
I hate disappearing taskbars. They drive me nuts. Anyways,
I know people who said it, so they disappear.
let's look at this function real quick. And let's graph it from 0. Let's go with 1 to 4. So that's what it looks like. Okay. Do we agree this is decreasing?
Yes.
How are you going to show that?
The derivative.
Let's work through it.
You take a remark,
So, what's the derivative? Okay, yeah, keep in mind there, thank you, Damon, that you can rewrite that as just a power rule problem.
So
Yep, which is -3 over x to the 4th, right?
Yeah.
Can that ever equal 0?
No.
Right, so we don't have to worry about critical points. Is there a discontinuity?
Yeah.
Where? There's a discontinuity at x equals 0, but is that in our
No.
domain? It's not. So yay, we don't have to worry about it. Okay. And then you're just going to do a sign analysis from 1 to 4. F prime at 2 is negative. You're decreasing. Right, so F is decreasing on 1, 4.
So you don't have to show both 2 and 3, you just choose it.
No, if there's no change, so the reason we set equals 0 is to show us if there's a change in the derivative sign.
Okay.
Because there's not, we know there's no change.
Okay.
We're good. Okay. So we know F is decreasing. You've just justified any answer you're going to give now. Right, so let's look at L3. Over or underestimate? Yep, so if you draw it in, right there, correct? It's an overestimate. You can see it. This is the algebra behind it. Okay. This is a justified answer now.
Question. So if you had a critical point between the interval 1 and 4, then you have to.
You have to do both. Yeah.
But since you didn't, you were able to just put F prime at 2 and then just exalt it.
Monte, what was your question?
I was asking if he had a critical point, if you were to have to analyze F prime at something else other than just.
Okay.
So like if it was a critical point at 3, he'd have to do between 3 and 4 and then 1 and 2.
R3 is
Underestimate.
underestimate. Okay. Okay, we'll make memory cards for this. Okay.
Do we have memory cards for antiderivatives yet?
You should have a few, but if not, we need to make some. Not time today probably, but we'll get to it. A long time before your next test. All right, so again, keep in mind, decreasing function, left is overestimate, right is an underestimate. And then with an increasing function, R is an overestimate, L is an underestimate. Switch
Is
it.
there
Question.
And there's no way that there's like an exception to that where R at one point would be an underestimate when it's increasing?
No.
Okay.
That determines it. Concavity does not have any bearing on this.
Okay.
Okay?
If that were to have like a critical point at like 3 and then it shoots right up, then you'd have an underestimate or
You
overestimate.
could not determine.
So like when the
Yeah, if this switched
When
from
that kind
increasing to
changes.
decreasing to increasing in the middle, we would not be able to determine over underestimates.
so you don't go into a process where like.
So
you
you're
say-
gonna, what you encounter is gonna be very straightforward.
Okay.
On the AP exam, it's just gonna be, is this an over underestimate? You show the derivatives, whatever, just make your statement, you're good. Okay, it's not gonna be anything way out there. Okay, questions here? All right. Let me put a star and just make this statement. Thankfully, midpoint sums.
Are always over.
We do not worry about over underestimates. There's no over or underestimate work. Okay. Honestly, I'm sure you could figure that out, but I don't even know how to do it. It's just not something that we bother with. Okay, so midpoint sums, we will not do any of this stuff.
And would trapezoids be the same?
No, we have to be able to do trapezoids. You said no?
Points as you go through it. Have your head.
All right, so let's talk about trapezoid sums. You put that away, yeah, there, Blade. Let's try a different function this time.
What time do we have this class?
Let's do trapezoidal sum with 2 subintervals for y equals sine x from 0 to pi over 2. Don't bother. Keep whining, I'll make it y equals sine 5x over 2 plus 8 minus 5x. Thank you.
How do you think you can remember all that these days?
I don't have to. I can just make something else up that's really difficult.
That's the nice part about being the teacher.
That's okay, I'll take notes on it still, and I still won't get it all exactly.
I get it, yeah, okay. So sine x from 0 to pi over 2. Has an amplitude of 1, right?
Right.
So it looks like, sorry, whoops. I picked pi over 2 for a reason. Okay, if we continued on, it would obviously do our normal sine curve, but we're just concerned with that interval. What's that? We want 2 subintervals. What's this value? Here's 0. Pi over 2 divided by 2.
Pi over 4.
Thank you.
I was like,
I can't hear you when you go like this. Oh man.
Wait, why?
Pi over 4.
Let's start. Why divided by 2?
We want 2 subintervals,
Oh.
so I just split it in half. All right, so your sum, trapezoid, right?
Wait, what? That's a triangle. That's right.
Yeah, because the height is 0. Okay, so again, we have the height, pi over 4, right? And then the bases are 0 and what's sine at pi over 4? Root 2 over 2. That's supposed to be 2. Okay. And then what's our other trapezoid area?
It's 1. The height is pi over 4.
Root 2 over 2 and 1. Okay, so there's your trapezoidal approximation, right? If it's free response. Which is. Okay. Same question arises. Is T2 an over or underestimate?
Under?
Okay. You can see that it's an underestimate. Yes? Okay, so T2 is an underestimate.
So it just follows the same rules as a left and so?
The problem here is we can't use the increasing and decreasing criteria.
Why not?
Because I can do a graph, this is increasing. I can do a graph that's also increasing. That is an overestimate, right?
So
So-
concavity matters in this one.
It's concavity that we have to check.
So second.
We have to use the second derivative, yeah. Yeah.
Where the two, wait, before you go farther, where the 2 divided by 2 come from?
So we have to check second derivative here. The divide by 2?
Yeah.
That's the area formula for a trapezoid.
1/2.
1/2, yeah. Okay, so what's the first derivative is what? Okay, and the second, right, set it equal to, check for critical values. Where is sine 0? 0 and pi, which are both outside of this interval, right? Thankfully. 0 is the end point. So our sign analysis again is just going to include our interval. F double prime at pi over 4. Negative. Right?
Right.
So concave down,
That's an under.
concave down. Trapezoidal sum is an underestimate.
So for all trapezoidal sums, we'll be using the
All
second
of them.
derivative?
Yep.
Let's say double.
Yes.
Yes. I kind of squeezed it in there. Sorry, you're going really fast. Just so excited about calculus. Okay, yep. So if we're concave down, a trapezoidal sum is an underestimate. Concave up, we would be yep, and then star this, concave up is an overestimate.
Is this a card thing?
Okay? Card thing?
Is this gonna go on the card?
Yeah, we will make memory cards for this. Okay?
This be our first integral card? These be our first integral card? Yes. Or is it going to be under derivative?
No, these are going to be integrals. We'll have left and right Riemann sum cards, trapezoidal sum, midpoint sum. We'll have over and underestimate cards. We're probably up to 6 or 8 cards right now that we need to make, huh?
What color are the cards gonna be?
We should do green.
Oh. What do you guys want to make? What colors did we use already?
Pink and orange. Let's do
We should
yellow.
do green.
We should do
Why
yellow.
would you ever want
Yeah.
the hideous neon yellow?
I really don't care.
Because I was gonna say something.
We'll start making those next week, okay? Good to go?
Okay.
Any questions?
No.
Again, using your derivative knowledge. Continue to be able to use derivatives, right? And why did I say second semester you get really much better at derivatives?
Because of this.
You just keep using them. If you keep working them, you're going to get better. Okay? Okay. That's next. We are on. Well, how about that?
Oh, the homework is gone?
Is it missing?
No, it's not missing.
Oh,
It's
dang.
wrong. Oh, that's what it is.
Bummer.
Dude, there's a glimmer of hope in everyone.
Yeah, I know, right?
I was excited and then now you
I got confused. Sorry.
We can do this a second. Was that 2011 or? Yeah. Obviously.
So a few free response questions. This will be due on Tuesday.
This is beautiful handwriting. Are these on topics like? Is it
Yeah,
on this
remember on
topic?
the left side I created the topics for Google Classroom?
Yeah.
The questions are all there.
Are these all on the first form or the second form?
They're all just the regular forms, it's not Form B.
Okay.
Yeah, if that's what you're asking.
Yeah.
When did they stop making different
2011-ish.
Why did they stop?
You know how much work that is? Yeah. It's just not necessary. Everybody takes the test at the same time. Okay, are we good? Sweet.
When did they get out of this class, you know?
5 after, I believe.